In this lesson, we're going to learn the various methods of finding objects and components at runtime so that we don't have to create the connections manually in the inspector and that we can do them quickly and easily. Now I'm just going to be opening up some scripts here. We use this method quite often inside of our game because it is one of my favorite methods of finding and connecting objects because it's so versatile and it doesn't require me to do a lot of work. For example, let's just jump into one of our scripts here. Let's jump into our spawn controller, and we use this actually quite extensively here. So the spawn controller was given a difficult task. We have to find all of the spawn objects. Now we could create an array here and assign them all manually inside of our game. But what happens when our level changes or if we want to add or remove spawning locations? Well, we would have to go in and change that in the script. Instead, what we were able to do is use the find game objects with tag function to grab every single tagged object with the term spawn. And this was incredibly easy to set up. For each of our spawn points, we just have to make sure the tag is spawn, and then Unity will automatically go in and assemble and grab all of these and put them into our respawns game object array, so that during the game we can randomly access one of these spawns and call the spawn enemy function on that object. So you can find all of these inside of the Unity reference by searching for find. We can search for transforms, game objects. You can see we can find an object of type, which is the first active object, or all the objects, which returns a list. And let's just jump into gameObject.find. And it's very simple. To assign something, it's just gameObject.find and then the name of the game object we need. For example, inside of our game state, we do this to connect to our player object. And inside of our hierarchy, if we drop down our player relative controls, this object is named player. And so the script executes and finds our player and connects it into our player control. Now we can also use this gameObject.find to connect in the components on our game objects, as we do down here. For example, with the waypoints, the waypoint controller, I didn't really need the game object. I needed a specific component on that game object, the control or the waypoint controller script, because this helps the enemies move around and find the player. So to do this, we used a gameObject.find along with a .getComponent into a variable of that type. So if we go up here to the top, let me hide a few of these functions just to make it easier to find. You can see we have this waypoint control variable cast into the script name or the script type that we wanted to grab, so that when we grab it or grab the parent game object, we can simply use the get component to assign a connection into that variable. Now this is an expensive operation. We definitely do not want to do a find every single frame. So the Unity tells us, for performance reasons, we do not want to do this inside of the update function, and we want to do this at the beginning at either an awake or a start, and then plug that into a member variable as we're doing here. And this is because it has to essentially go through every single object in our hierarchy and search for a specific name. And when you have hundreds of objects, for example, our environment is really deep, we can see that iterating through each of these on every frame would get very slow. So we always want to do the pattern of create a member variable to store that connection, and then at the beginning of the script, we create that connection, and then in the update function, we just deal with the variable, and we're no longer looking for that object. Now this finding method is extremely useful for when we create objects dynamically. For example, our enemy is created at runtime, so we're copying this into our hierarchy at runtime. So we don't have the ability to go in and connect things in the inspector. So what we can do is when the enemy is created, we can find the player object by another game object, find with tag. So our player object has the tag player, and so the enemy automatically knows that this is where it needs to connect, and it creates a connection to this object very quickly. So the default find is the slowest of the functions. If you can, I would use find object of type or one of the typing ones, or you can also use the find with tag. So we see here we have find game objects with tag and find with tag. And those are also incredibly useful for speeding this up, because looking through the tag system is much faster than looking through every single object that exists in our game. Now this does require that we know the name of the object, or the type of the object, or the tag of the object. Now for a type, for example, we have only one game state script in our entire scene, or in our entire hierarchy. So we could search for the type of game state, and it would return this component on this specific object. Now let's talk briefly about the downsides to this way of connecting. One is that it's still just a direct connection. So script A is still directly connected to script B. For example, our game state is still directly connected to these other scripts. They're directly connected to the player and to the waypoint. So if you want to add a new connection, you need to copy this line and add in another line. And then write, of course, all the code that you want to interact with that object. We also have the possibility of mistyping or destroying the object we're trying to look for, in which case this game object at find would return a null, and then when we either tried to access this or when we tried to change it, we would get a null reference exception or a reference does not exist exception, and it would crash our game. So we have to be careful that we are actually correctly finding the objects, and if we're not, we need to deal with that situation of we cannot find this object, so we need to either try and find it again or do some sort of exit code or error code. And the last problem is, of course, it's slow if we do it too often. Here we're only instantiating, I'd say, at maximum 20 objects at a time, each one maybe calling 2 or 3 finds. So that's only 60 finds that need to happen at any given point in time. Of course, you can really overburden your code with this, and it's very easy to write this code and have it connect correctly. But again, if we overuse this, or if we try and use this for many objects every frame, it's going to bog down our system. Still, it's a very nice way of connecting objects together if you know their name, their type, or their tag. So in the next lesson, let's take a look at how we can connect scripts together using the physics of the game, as well as the send messages, which we'll get into more in a later lesson.